Lasing action. The lasing action is the combination of spontaneous emission first, and then stimulated emission. It causes the laser to lase, means light amplification by stimulated emission, which means it generates a coherent beam of light with a single frequency. The laser produces a unique light. The laser has characteristics like monochromatic, directional, coherent intensity, optical intensity. The monochromatic means it consists of a single color or wavelength. Directional means that beam is well collimated or very parallel and travels over a long distance with very little spread. Coherent means that all individual waves of light are moving precisely together through time and space. It means they are in phase. Intensity. The intensity means optical intensity is the optical power per unit area. Optical power per unit area. The unit is watt per meter square or the watt per centimeter square. Very high optical intensity can be generated by the lasers. So coherence in the length emitted by normal light wave is coherent for about few millimeters for the normal light, whereas in case of lasers this coherent length is up to kilometers. And this relation of the coherence length is given by this equation: L coherence lambda square divided by mu is refractive index, delta lambda. Directionality you already know. Divergence or the angular spread of the laser beam, it is also given by this equation, 1.22 lambda by t or lambda by t. Monochromaticity also you already know. There are many types of lasers: solid state laser, gas laser, dye lasers, excimer lasers, semiconductor lasers. In the solid state lasers, the lasing material is distributed in a solid matrix, in solid environment, solid matrix. For example, in the ruby or Nd:YAG, neodymium, or the Nd:YAG ytterbium aluminum garnet lasers, the Nd:YAG lasers emit infrared light. It's about 1.064 micrometers. In the gas lasers, helium-neon laser are the most common gas lasers. It's the primary output of a visible red light. Another is CO2 lasers. The CO2 lasers again, the energy emitted in the range of far infrared, 10.6 micrometers, and are used for cutting hard materials. Dye lasers. Dye lasers use complex organic dyes like rhodamine 6G in liquid solution or suspension as lasing medium. So you know that the active medium, optical pumping, and optical resonator. These are the three main components to make laser. So in this, the active medium, so these are all the using in the solid state. The active medium uses ruby. The gas laser active medium is helium-neon mixture or CO2. Dye lasers active medium active medium is rhodamine. Another is excimer lasers. This name is derived from in terms of excited and dimers. In these lasers, reactive gases is used such as chlorine and fluorine mixed with the inert gases such as argon, krypton or xenon. The lasers produces the light in the ultraviolet range. Semiconductor lasers are sometimes called diode lasers, but they are not solid state lasers. These electronic devices are generally very small and use low power. For example, the writing source in some laser printers or compact disc players. First one is ruby laser. In the ruby laser, there are main component is for the active medium is ruby crystal. Pumping source is a xenon filled flash lamp. This one is xenon filled flash lamp, and usually it is lit by a capacitor dump few thousands of joule energy, and its flashes for 1 milliseconds. For the optical resonator, a pair of mirror, one is partially and other is fully reflecting, is used. So here for the xenon filled flash lamp, okay, for the lasing action or the principle, and the atoms from the ground state, it will absorb the photons and goes to the excited state, and very immediately it will come down to the metastable state. In the excited state, that lifetime is very short, it's 10 raised to minus 7 seconds, and in the metastable state it's staying longer time. That's why it's metastable. And from the metastable to comes to the ground state with the stimulated emission, and you will get the single wavelength monochromatic coherent light means laser, the wavelength of 6943 angstrom. Another is helium-neon laser. The helium-neon laser, you can see here the cathode and anode for the produce the discharge. The active medium is helium-neon reservoir. The optical cavity is this output coupler and high reflector mirror. You can see that from the cavity laser will emerge. So main component active medium, pumping source and optical resonator are shown in this figure. Next, if you understood the lasing action, so here also it's very simple. When the electron collides with the helium atom, stimulated absorption happens, and this helium atom goes to the excited state, and from the excited state the energy transfer to the ground state of the neon atoms, and the neon atoms goes to directly E6. This is the metastable state, and from here the stimulated emission happen from the E6 to E3, E6 to E5 and E6 to E3, so E4 to E3, and it will generate the wavelength 6 6328 angstrom, 3.39 micrometer, and 1.15. So these are the wavelengths. These are the radiation in the infrared, and this one you can get the desired wavelength. So these two radiation is absorbed by the optical cavity, and you can get only a desired wavelength 6328 angstrom. So more detail we will learn in construction and principle of helium-neon laser. So now we will understand in detail ruby laser construction and principle. As you know the ruby laser, this one is the crystal, this one is the tube which contains xenon. The ruby mineral is the antimonium oxide with a small amount, the 0.05 percentage of the chromium, which gives it its characteristic pink or red color by absorbing green and blue light. The ruby laser is used as a pulse laser to producing the red light around 694.3 nanometer wavelength. After receiving a pumping flash from the flash tube, the from laser light emerges for as long as the excited atoms persist in the ruby rod, which is typically about in millisecond. So here is energy level diagram for ruby laser. The green light and blue light absorbed, atom goes to the excited state, and non-radioactive transition to the metastable state from the pumping levels, and from the metastable state goes to the ground state. A stimulated emission happens, and the desired 694.3 nanometer laser can be generated. And for a ruby laser, a crystal of ruby is formed into a cylinder. The rod's ends had to be polished with great precision, such that the ends of the rod were flat to within a quarter of the wavelength of output light, which is flat to within a quarter of a wavelength of the output light, and parallel to each other within a few seconds of arc, almost perfectly parallel, few seconds of arc. The finely polished ends of the rod were silvered. One end is completely silvered, another is only partially silvered. The rod with its reflective ends then acts as a fabric pellet, cavity or fabric pellet, eternal. The xenon lamp is rolled over ruby rod and is used for pumping ions to excited state, goes to the metastable state, happens, goes to the ground state, and the laser generated. The application of ruby crystals. Generally, the ruby lasers have declined to use with the discovery of better lasing media, but still there are a number of applications are there. Short pulses of red light are required. Heliographers to make or produce holographic portrait with ruby lasers the size of around meter squared. Many non-destructive testing use ruby lasers to create holograms of large objects such as aircraft tires to look for weaknesses in the lining. Ruby lasers also used to in tattoo to making the tattoo and hair removal. Helium-neon laser. The helium-neon laser is used here for the electrical discharge method. Anode, cathode, and anode is there for the active medium is helium-neon gas. Optical cavity is high reflector and partial reflector, and you will get the laser. So gas lasers usually employed a mixture of two gases, say A and B. Atoms of kind A are excited through the impact of electron, and they transfer their energy to another atom like B, which are actually plays the role of active centers. The gas lasers uses gas like helium, neon, argon, etc. and excited normally through the electric discharge pumping. This setup consists a discharge tube of the length is 80 cm and bore diameter is 1.5 cm. The gain medium of the laser is suggested by its name mixture of helium-neon gases in the ratio of 5 Gen 1 to 20 Gen 1. It's contained a low pressure in a glass envelope. It's around 50 Pascal per centimeter of cavity length. The energy at the pump source of the laser is provided by an electrical discharge is around 1000 volts through an anode and cathode at each end of the glass tube, and a current of about 5 to 100 milliampere is typical for continuous wave operation. The optical cavity of the laser typically consists of a plain high reflecting mirror at the one end of the laser tube and a concave output coupler mirror is approximately transmission is 1% to the other end. The helium-neon are normally small with the cavity length of about 15 centimeters up to 0.5 meter and the optical output power ranging from 1 milliwatt to 100 milliwatt. So this is the energy level diagram for helium-neon laser. There are many materials or many books shows the energy. Sometimes it will be E0, E1, E2, E3, E4, E5, but I am preferring this one. You can also use this one also, but for the explaining I am using this one because most of the explanation are based on this energy level diagram. The here the helium-neon excitation process is basically given in terms of following four steps. In a simple way, if I explain this one, so when the electron collides with the helium atom, it goes to the 210 and this is another 2s1 and 2s0 levels, and atom will transfer its energy, excited atom, helium atom transfer its energy to unexcited or the ground state neon atoms, and this ground state neon atom goes to directly into 3s level, and from the 3s level there are two radiations. One is 3.39 micrometer and 3s2 2p 632.8 nanometer, and another transition from 2s to 2p 1.15 micrometer. So when the helium atom transfer the energy to neon ground state atom, that neon ground state atom goes to the metastable state. This is the metastable state, and here the population inversion happens between the 3s and 2p states, and these are the radiations happens, and these two radiations are in the range of infrared. So this will absorbed by the optical cavity You will design optical cavity like this. These two radiation will absorb only desired radiation you can get. That one is 632.8 nanometer, and from this level the fast radiative transition, the spontaneous emission will happen. An atom will come to 1s state, and from 1s state the atom will directly goes to the ground state, means it will collide to the wall. So this is the simple principle. It will go like this. In this excited helium atoms interact with the collision with the neon ground state neon atoms. The ground state neon goes to the 3s, and from 3s to 2p, and from 2s to 2p. These two are absorbed by the cavity and desired wavelength you can get. So now we understand in this way, when the power is switched on, the energetic electron collides or the collisions happen, and excites a helium atom to the state labeled 21s. As the electron has smaller mass, it can accelerate easily compared to the heavy neon atoms. This excited helium atom collides with the ground state neon atom. Ground state neon atom, and this atom exchanges the internal energy with the helium and neon atom. In this energy exchange process occurs with highly probability only because of the accidental near equality of the two excitation energies. Actually it will goes to the resonant because of the these levels and energy of these levels are same, so resonant transfer occur. It can help to create continuous population inversion with high probability only because of the accidental near the equality of two excitation energies of two levels in these atoms. Thus the purpose of population inversion is fulfilled. And these excited neon atoms passes through the metastable state 3s, and goes to the lower level 2p. This one 2p. It emits a photon of wavelength 632 nanometer. This photon travels through the gas mixture parallel to the axis of tube. It is reflected back and forth by the mirror end until it stimulates and excites the neon atoms and causes it to emit a photon of 632 nanometer with the stimulating photon. In this stimulated transition from 3s to 2p level is laser transition. This process is continued, and when a beam of coherent radiation becomes sufficiently strong, a portion of it escapes through the partially silvered end. The neon atom passes to lower level. This neon atom passes to lower level 1s, emitting spontaneous emission, and finally the neon atom comes to the ground state through the collision with the tube wall and undergoes radiationless transition. So this is working principle and construction of helium-neon laser. Application of helium-neon laser is the narrow red beam of helium-neon laser is used in the supermarket to read barcodes. The helium-neon laser is used in holography in producing the 3D images of the objects. Another application is used in the industrial and scientific fields, and are often used in laboratory demonstration of the optics. Okay, so Today we will keep it this topic up to here, and your laser topic now is finished. Thank you.